Welcome viewers, this is TTB Tutorials. On today's topic, we are going to learn another chapter, which is Principle of Mathematical Induction. This is one of the methods that we use in mathematics to prove whether this number is mathematically correct or not. So let us see the definition. Uh, Mathematical induction is one of the most techniques used to prove in mathematics. So we use these techniques to prove in mathematics. So it is used to check conjectures, okay, about the outcome of processes that occur repeatedly according to definite patterns. So when you have numbers that you have doubt on them, okay, you can use this mathematical induction to prove such numbers. Okay, so this mathematical induction it is also used to prove different proposition involving positive integers using three steps. So for this, as we are going to go through some examples, we are going to follow three steps. We have step one, step two, step three. So all these steps that are already used in this mathematical induction. So the first step is to prove that uh, T true, K always true. Okay, like now it is true for the first. It is always true for the first. For the first step is always true. Okay. Then now the second step is assumption. You can assume that this may be true, but later on in step three you can prove that assumption in step two. You can prove it in step three. So step three we can simply show that what we have assumed in step two to make it real. Okay. So now let us see how we can prove some numbers. Okay. For instance, we are given some examples. Let us see how we can prove these examples. Now we have example one. They say show that. Now we are trying to show if this is equals to this. So they say show that 1 plus 3 plus 5 plus there's a number here, okay, but we don't know. Plus 2 2n minus 1 equals to 2 raised power n 2 power n power 2. Okay, n power 2. So now we are trying to prove. Let us prove if this is equal to this. Okay, let us prove if this is equal to this. So now here, as I said before, we have three steps. The first step is step one. Step one. So for step one, n is always 1. So step one, n is always equals to 1. N equals to 1. Okay. So now let us solve. If it will give us. So for step one, n is equals to 1, natural number 1. So let us prove it. So it is 2 n minus 1 equals to n squared. Okay. So now you substitute the value of n with 1. So it will be 2 times 1 minus 1. Okay. Equals to 1 squared. So here we are getting 2, 1. Then we are getting 1 equals to, here we are getting 1. So when we subtract this, we are getting 1. So meaning 1 equals to 1, meaning it is true. Okay. It is true. So meaning for the first step, this one is equals to this. It is true. We prove it. It is true. So now let us come to step 2. So step 2, we are just going to say assume step 2. So step 2, assume that uh, n equals to k is true. Assume that n equals to k is true. Okay. In step 2, n is always equals to k. Okay. So now let's see. N is equals to k. So it will be 1 plus 3 plus 5. Then we have 2n minus 1 equals n squared. Okay. So now every value of n you put k. Put k. So now we have assumed that uh, n equals to k, which is true. So now this is the assumption that we made. Okay. So we are assuming that it is true like this. It is true. So now let us come to step 3. Come to step 3. So in step 3, it is whereby we are going to show that this statement is really true. Okay. So now in step 3, show that n equals to k plus 1 is true. Okay. So let us now, this, since we say n equals to k plus 1, so the value of n, we are going to substitute this here. Okay. So now let us bring this 1 plus 3 plus 5 plus we have 2n 2n plus is minus 1 then equals to n squared. So now every place that is having n, you substitute this. So now let us put the claim 1 plus so let us now put every value of n with this. Okay, with this. So now it will be 2. Okay, 2. Now k plus 1. Okay, then minus 1. Okay, then now equals to bracket k plus 1 squared. Okay, then now from there now when you work out this, so it is 2k, then 2, then here let us just now write those statement. It will be 2k. Okay, 2k plus 1. Okay, when you write this, the full statement of this will give you 2k plus 1. Okay, but now this is the claim. Okay, this is the claim. So now let us also we are also going to bring this statement. Okay, so this is claim. Then now will be 1 plus 3 plus 5 plus we have 2 minus 1, then we have then plus we have 2k plus 1 that equals to k plus 1 squared. Okay, so now since we have solved this now, let us see this one from here. up to here. It is in the second step. It is in the second step, which is this. So the whole of this one is equals to k squared. So meaning the whole of this one is equals to k squared. So meaning now uh, from the claim here, okay, from the claim here, we got this, okay. From the claim we got this, okay. So now we are trying to solve the claim. This is the claim statement. They say it is equals to this, okay. So now let us make this claim statement. This one will be like this. So now after us bringing the whole claim statement, okay, now let us prove this one. So since we got this one to be k squared, then now k squared, this is k squared, then plus 2k plus 1, okay. Now this statement, it is what we are going to get here. So it will be k squared plus 2k plus 1, okay. So now after getting that one, then now we can prove this to be this, okay. So now for us, let us k squared. Now we want to make this one to be in this form, okay, in this form. So for us to get this one in this form, let us, we now k, since this one it is 2k, let us separate this 2k so that we group them differently. So it will be k plus 1, whereby here let us group this into groups. So from here we are going to get k squared, you substitute this k, then from there we are remaining with 1k, then from here plus, here we are remaining with 1, then plus, here which number is the same here, we are having 1. So from here we are getting k plus 1, of which now you take the outside numbers. We have k here, we have 1 here. So here we are getting k plus 1. K plus 1. Since this one and this one, they are the same, you take 1. So it will be k plus 1. So from there now, this, if you are to see, this and this, they are the same, okay. So in this form, it will take us to k plus 1 squared, of which it is what we are looking for. So if you are to take this one back, this k plus 1, it will give us, it will still take you back to k, because they are the same, okay. So this one and this one, they are the same. So for you to make it into this format, okay, you will just square 1 to show that these two, they are like this, okay. So k plus 1. So this one can take you back to this, okay, when you multiply the two this. So now the major proof that we want to prove is that this claim statement can take us back to this. So this is the answer that we are looking for. This is the answer we're looking for, that this one is equals to this. Since we prove it, now this one is equals to this. So this is the answer. Yes, student, this is example 2. So example 2, it is just the same way you are going to solve it. The same 3 steps that we have used in the first example, the very steps that we will use also in this very example. So now let us see. Step 1, let us prove. Step 1. Okay. Step 1. Let us now prove n equals to 1. N equals to 1. So now we are proving that n equals to 1. So let us prove if this statement will be equals this. So now it will be n equals to n open bracket n plus 1 out of 2. So now we have n equals to 1 equals to 1 1 plus 1 out of 2. So now here we are getting 1 equals to 1, then we having 2, we having 1. Okay, so n number multiplied by 1 is that same number. So we have 2 out of 2. So 2 out of 2 will give us 1. So uh meaning here we are getting 1 equals to 1. So meaning it is true. Okay, it is true for n equals to 1. Okay, it is true for n equals to 1. So now let us see step 2. Step 2 is about assumption. Assume that it is true for n equals to k. So now you assume that it is true for n equals to k. So now it is 1 plus 3 plus 5. Okay, then plus, then equals to n plus this k. We are replacing every value of n with k. So we are assuming that this is true. Okay, we are assuming that this statement is true for n equals to k. So now let us come to step 3. Step 3. Step 3. Show that it is true for n equals to k plus 1. So we are trying to show that for sure it is true for n equals to k. So now it will be 1 plus 3 plus 5 plus k plus 1. Okay, plus 1. Here in the statement, we have the claim statement, we have k, then plus k, then equals to, now the value of k will be k, this n. We have this n, we have this n, we will replace by this, so it will be k. Then we have this, we have k plus 2, k plus 2 out of 2, because now when you bring here will be k plus 1, then plus this one again will be 2. So now we are trying to prove that this statement is equal to this. Okay, so now this is the claim statement. This is the claim statement. This is the claim statement. So now let us say now we will have 1 plus 3 plus 5, then plus k, then plus k plus 1. So since we know that the whole of this statement it is the step 2. Okay, it is the step 2. So now the step 2, what does this one represent in step 2? Let us see. In step 2, it represents this. Okay, in step 2, it represents this. So now in step 2, it will be this. It will be K, open bracket K plus 1. Okay, out of 2. So meaning the whole of this one, the whole of this statement, it is this. The whole of this statement, it is this in step 2. Don't get confused. The whole of this statement, it is this in step 2. So now, if this, this one, which is this, plus this, okay, plus K plus 1. Okay, so now let us solve this one. If this one will bring to us this, okay, so now it will be K, okay, it will be now K, this one will be K squared, okay, K squared, okay, this one will be K squared, then now, then will be K, okay, then plus K 1, then out of 2. So now let us get the LCM of this. Okay, the LCM of this will be now 2. Then here we are getting K squared plus K, which is this. Since 2 and 1, the LCM is 1, is 2. So now we are getting this, the LCM will be 2. Then our 2 will plus 2 K plus 1. Okay. So now, after us getting this one, so now we can be able to get this. Okay, we can be able to get this. But now, even we can now, before even we can leave this. Okay, we can leave this like this. So I think yeah, we can express this one in this format again. Okay, we can express this in this format. Okay, so now let us take it back to this format. It will be K plus 1. Okay, then plus 2, then K plus 1. Okay, out of 2. Okay, so instead of you expressing this in this format, you leave it the way it is like this. Okay, leave it the way it is like this. So now after bringing it like this now, then from there you will notice that we have these two brackets, they are the same. Okay, so now what you will do, you will take the numbers that are outside the bracket, you add them together, whereby you're going to get K plus 2. The reason also why you're using plus sign, it is because of this plus sign. So it is K plus 2. Then since we have two brackets that are the same, okay, two brackets that are the same, so you take one. So now instead of you will now say you will now take only one bracket. Okay, one bracket from this. So now you take one bracket, it is K plus 1. Okay, so now then don't forget to put the LCM. So it will be this. Okay, so now after getting this, so this will be your final answer. Okay, K plus 1 out of 2. So this is what we want to prove. Okay, this is what we want to prove. So you first see the claim, and now the claim. This is the claim. Okay, this is the claim. So they are claiming that the whole of this statement is equal to this. Now, is it true? You first compare this with this. If it is true, so you can see this statement, we prove it that it is true for this. Okay, so this is what we are looking for. This is the final answer. This is the final answer. So let us see example 3.